Hey everyone, my name is Seth Adams. This is the first lab for Physics 2, the charge tape lab. For this, we're going to have our main ideas first, the use topics for this lab, the results of this lab, and then some additional notes at the end. The main idea of this lab focuses on charged particles, neutral matter, and their interactions with each other. And we also need to find the amount of excess charge on the Scotch tape. For our use topics in this lab, one of the big, more important things is Coulomb's law, which is F equals 1 over 4 pi epsilon naught times Q2 over R squared times R hat, and then Newton's third law. It's a big principle. Quickly for the results, the tape is negatively charged. When the two tapes get real close to each other, they repel, and they attracted to a neutral matter and repelled negatively. The tape has 3.79 times 10 to the 10th excess electrons, and the tape itself has a charge of 6.07 times 10 to the negative 9th coulombs. Notes and assumptions for this lab. The system in this experiment was the charged U-tape and the objects that it was interacting with, whether that be the U-tape, my hand, my pencil, etc. Air resistance and other external forces can be ignored due to their insignificant effect on the results of the experiment. They really didn't change anything. And we can assume that the charge is evenly distributed throughout the tape and that each charge is the same for each piece of tape. For the initial conditions of this experiment, we started with a piece of U-tape that was 20 centimeters long, which converts to 0.2 meters. The tape weighed 0.2 grams, which comes out to 0.002 kilograms. And we had the distance between the two at 1.3 centimeters, which rolls out to 0.013 meters. For the calculations on this lab, we found the force of gravity equal to 0.002 newtons. Fe and Fg are equal to each other, so we both know that they're 0.002 newtons. To find Q, we plugged everything in that we needed using the Coulomb's law to get Q equals 6.07 times 10 to the negative 9 coulombs. And to calculate the number of excess electrons, we can then take Q over E. And by filling that formula out, we get 3.79 times 10 to the 10th electrons. So that's how many excess we have on the tape. To find the area of the tape, we did a little measuring, and it's length times width, and came out to 0.0038 meters squared. And to do the math on the number of atoms, pretty simple. You just take your charge and multiply by the area, and we get that there's 3.8 times 10 to the 17th total atoms on the tape. To calculate the ratio of electrons to atoms, we put the number of electrons over the number of atoms, and we get that there's 9.97 times 10 to the negative 8th electrons per one atom. Here is our glow script model. You can see right here, it's got the charge of one piece of tape being 6.0697 times 10 to the negative 9th coulombs. And here is my glow script code for this model. Some potential sources of error in this experiment, they can pop up from some of the assumptions that we made earlier, like ignoring all the external forces, and assuming that the charge is evenly distributed throughout the tape. Another source of error could come from considering the tape as a point charge instead of a line charge, which would be more accurate because of the multiple charges throughout the piece of tape. What would happen if the electrons were positively charged and protons were negatively charged? That this experiment wouldn't change at all. Nothing would change because positive and negative charges will still attract and like charges will still repel each other. Why are the charges different between the point and the line charge models? This is because in the line charge model, atoms in the top tape are experiencing forces from multiple sources on the bottom tape. This means that the line charge is the most accurate model out of these two. And that is all I have. Thank you. Y'all have a good day.